Good morning, students. Good morning to all of you. Let us see the question of 48. A train covers a distance of 300 km at a uniform speed. Okay. Let us see the solution of this question. Let's suppose the train is starting from A and it covers a distance that is 300 km. Okay. At a uniform speed, the speed we assume that is v1 equal to x km per hour. We assume it if the speed of the train is increased by 5 km per hour. This one the first case, you assume that this one the first case, and as you increase your speed by how much is given 5 km per hour means you increase your speed that is v2 by 5 km per hour means from at the first case speed we have to add by 5 so that the speed is to be increased by 5 km per hour. So the second case speed becomes how much? X plus 5 km per hour. Okay, this is the second case. It takes 2 hours less in the journey if the speed is to be increased by 5 km per hour. From the previous speed, the time taken by the train will be decreased by 2 hours. Okay, so here the time will be decreased by 2 hours. Okay, in the journey, find the original speed of the train. The distance is same for the whole two cases. Okay, both the cases the distance is same means here the s1 that is becomes how much 300 km and here s2 that is also 300 km because the same path the train is to be running. Okay, so 300 km also the s2. So our planning is to find out the t1 that is the time taken by the train in first case and the time taken by the train by the second case after increasing the speed by 5 km per hour. Then we will compare to each other and we will subtract the in first case by 2 because 2 hours less time taken by the train in the second case, so we will subtract by 2 in the first case and we will equate it. Okay, let us see here according to questions if you find the t1 that is the time taken by the train in first case, that is t1, you can write here first case t1 you will find that t1 that is t equal to s by v, that is s1 by v1, the s for distance and v for speed. So s1 becomes how much? S1 that is 300 km by v1 that is x, and in second case that is the t2 that we have to find out s2 upon v2, and distance is same because the train covers the same path, so v2 becomes how much? X plus 5. And we know that according to question we know that we can write the 300 upon x and it will be equal to 300 upon x plus 5, and we know that this time is lesser by 2 hours. So we will subtract 2 in the first case so that it can be equate to each other. So after it we will solve it 300 upon x and minus 300 divided by x plus 5, and it will be equal to 2, and from here as you take 300 as a common you get how much? You get 1 upon x and minus 1 upon x plus 5, and it will be equal to 2, and as you cancel the 300 by 2 you get how much? 150. Okay, and we know that 1 upon x minus 1 upon x plus 5 it can be written as 1 upon 50 because 150 go to the denominator of 1. Okay, so from here we know that the LCM of x into x plus 5 it will be becomes like that, and from here x plus 5 minus x, the x will be cancelled out and it will becomes 150, and from here we can write 5 upon x square plus 5x equal to 150. We can write x square plus 5x. From here by cross multiplication x square plus 5x equal to 15 5 ja, how much? 15 5 ja 75, that is equal to 750, and from here we can write that is x square plus 5x minus 750 equal to 0. After factorization we will to set to become 5x. Here we factorize 750. Okay, 5 1 ja 5 15. Okay, and 5 3 ja 15, 2, 15, and 3, 15. So we will set to become 5 here. 5 5 25, and 2 3 just 6 5 30. So from here to here it will becomes 25, and here it will becomes 30. 2 3 6 5 30. So we decided to write 30x minus 25x. So here x square plus, in place of 5x we putting here 30x minus 25x minus 750 equal to 0. 750 equal to 0, because 25x, because as you subtract 30x minus 25x you get 5x, but as you multiply you get 750 in negative sign. So from here, as you take common, that x plus 30 will be remaining, and minus 25 you take common, then x minus how much, x plus 30 also be remaining here. So from here you can take a common, that is x plus 30 as a common, and from x minus 25 as a, the remaining portion x minus 25 after taking common, then x equal to minus 30 and x equal to 25, and we know that speed cannot be negative, so x does not equal to 30, so our answer is x equal to 25. So the speed that we assume in first case, the speed we assume, that is the original speed of the train. So we can write here the original, this one, the speed of the train, we assume original speed of the train. Okay, you can write here original speed. Okay, so the original speed of train equal to x equal to 25 km/h. Okay, I hope you are able to follow me. Thank you very much.